Thanks for coming to the session. My name is Steve Tegler. I'm a director of what we call technical product managers and SEs in our cloud native applications business unit. With me is Frank Carta, who's a consulting architect. You want to explain what you do?
So I'm a consulting architect with the PSO group. We used to do a lot of DevOps. We've kind of migrated into the SDDC group now. But I go around and do a lot of these release pipelines and CI/CD type engagements.
Great. So, a tale of IaaS infrastructure as code, the role of containers in CI/CD. Standard disclaimer, don't buy anything because of what you see here. So, I want to just, 3 quick questions here. Who's here because they don't know what they don't know? Okay, I think that's everybody, almost. Who knows that their apps team actually do have a CI/CD pipeline? Yes? Couple. Okay. And then anyone leverage infrastructure as code today? 1, 2, 3, so a few, some, dabbling. Great, thank you. I want to iterate here, this is not a best practice session. Like, if you look at CI/CD pipelines in general, like, it is everything, and there's different terminology used everywhere. This is one example, so highly generic overview, and your mileage, and by me mileage, opinions will definitely vary in your organization. You might come back and say, hey, what do we do in staging? And they look at you cross-eyed. Oh, you mean pre-prod? So there's some things like that going on. So I just wanted to highlight that this is not some sort of best practice. This is all about concepts and how things flow. Here's the kind of formal agenda, so to speak. I need to set the stage around CI/CD here with agility and speed. So I'll kind of preface the conversation with what's going on, in the industry in terms of how are we actually building software more quickly. Then I'm going to actually go through the definition here of CI/CD, and we talk about continuous integration. And then the D either means development or deployment. Okay. And then Frank is going to do a demo of just kind of how it works today, just typical software developer, no infrastructure as code or anything, okay? Then we roll into what is the infrastructure role or IaaS role as a part of this whole software development process. Then we'll talk about a couple of different IaaS options from VMware that we have. We actually have 2, vRealize Automation and VMware Integrated OpenStack. And then Frank's going to do a demo where we actually demo using infrastructure as code to provision the app and so forth. And then we roll, at the end here, we're going to talk about containers. I don't know if we'll have time for a demo because we've got a lot of content. Obviously, we always like to fill these things with content, but we'll see how that goes based on questions at the end. Okay. So agility and speed. This is the name of the game. I'm guessing everyone here has an initiative to go faster, move faster, create, a lot of app teams are like, how do I get that app out quicker, okay? So kind of 2 big things here. The way you do this is that you streamline the whole application release cycle, like from committing code all the way to moving it to production. And the 3 kind of generic areas here, after I create that software artifact, it's called, I push it to a test environment, I move it to something called staging, and then I move it to production after that. Now, what's interesting, if we think about it from an infrastructure perspective, the infrastructure at those different stages is probably different. Either it's a different VM, sometimes it's a different operating system, different network configurations, IP addresses, SSH keys, you name it, it's different. And that is the enemy here. Because as you run through testing, that environment that you're testing on is not the same as staging, which may not be the same as production. And that is the enemy here. So what we want to do is we want to automate the deployment of that infrastructure. So that's where a concept called infrastructure as code comes into play. And then another thing called configuration management and potentially even containers in that space to help make it be a more ubiquitous infrastructure that the application developers can talk to. We need to modify this pipeline and help it out by actually provisioning the infrastructure right before we actually provision that application. And so the consistency and the frequency will end up reducing the difficulty. I mean, it's the whole waterfall agile. Like, if it takes me 2 months to run through this process, I'm going to have to batch up a lot of changes, and that's way more risky. If that process is super efficient and I can commit a change and maybe a day later or hours later that effect or that change takes effect, then in effect I can make lots of little changes very frequently, and that's much, much easier. So the 3 technologies from VMware that help there, VMware Integrated OpenStack, vRealize Automation, and some of our container technology. And you've probably heard about this modernization of the application architecture, going from monolithic to microservices. The hard part here is that if you don't have an efficient pipeline to begin with, it's going to be really difficult to make changes to that software, that monolith, to break it apart. So I consider the top section a prerequisite before you can move on to modernizing your application architecture. If that's not efficient, it's going to be really hard to make changes and evolve this monolith. So when we do talk about this, we talk about containers. Do I use containers, VMs? Where's the state of the app? Where's that held? Lots of times is a long journey. I think the Netflix example is like 3 or 4 years it took them to break apart their thing. It's not easy, right? And that's why it's highly critical that we can, evolve that monolith extremely efficiently. So a couple of technologies here that help as you're getting to the modernization of the application architecture. So vSphere integrated containers, of course, is one. But then we also saw the announcement yesterday, PKS is another one, VMware Pivotal Container Service. So let's get into continuous integration, development, and deployment. And this is really about building this software factory. And so this is, again, highly generic view here. On the left-hand side, you see code development. This is when the humans write the code, right? And they commit it to a source control. And what happens then is that code from the different individuals is all put together, and you create this software artifact. That's like a jar file or something like that. Okay, that's the continuous integration piece. From there, we go on to testing, staging, and production. And testing can either be fully automated if you're really good at this, or maybe you've got some user testing where someone has to click on something and try special things. We move it to staging. The big thing with staging is that it tries or it needs to mimic production as much as possible. You want to be able to test that thing in the exact same environment as production, right? Maybe there's some load testing and some other things that happen there. So that's like the final testing before you actually move it to production. So when I look at continuous delivery and deployment, continuous delivery, what that means is that you go all the way through to staging, or sometimes it's called pre-prod, and then you stop. And that's when you need a human being to say, okay, push it to production. Okay, because you just want that last little check, like, is this right, are we good? Continuous deployment pushes it all the way to production. So if you've ever heard the term like 1,000 deploys a day or whatever, like there's a lot of companies out there, Amazon.com, Etsy, you name it, right? They're committing code and it's automatically moving to production. And I'm not here to say this is easy, this is hard. It's really hard to do, okay, to optimize this thing. But that's the difference. When you hear the D, it either means delivery or it means deployment. Depends on who you're talking to. For the most part, it's delivery. So let's focus in on kind of this first part, which is the continuous integration piece. So here we are. We've got the coders here on the left-hand side. They're all writing code and they're checking it in to source code management, something like Git, where it all gets deposited. And then what happens is there is this engine, call it, or a build or a continuous integration engine that basically watches the repository. And as it sees these changes and commits, it will take action on that. And so the first action is that it runs these kind of simple build or unit tests, a couple of quick tests to make sure the code is right. And if it passes that, then what it does is it creates this thing called a software artifact. And a software artifact is like binary, it's a jar file, a war file, or I even threw OVA in there. Because if you think about VMware, we've got this product called vCenter, right? How many different teams are working on that product, right? So our software artifact is an OVA, okay? So there we are, software artifact. So now the code is quote unquote integrated because now we've got the software artifact. Now we move on to the testing and staging. And so here we are continuing on the continuous delivery and deployment here. We've got continuous integration. Coders are out here. Coders are out here writing code. And then we've got that build engine. Forgot to mention that. So what is that build engine? What is that software? That's like Jenkins, Concourse, TeamCity, lots of different technologies out there to do this, but those are some of the big ones. So that sits up here on top. Now typically what happens is a part of that engine that's doing this, it has to be configured to go talk to our different environments. So here I've got 3 testing environments, I've got staging, and I've got production. Okay, so most likely, like today, it's probably, you've got to have this, I call it the glue, where that process will go out to probably a set of VMs. And largely it could be like IP addresses hard-coded, right? To be real about this. And so I have to hard code that probably up here, and it goes out to these environments, and I have to create this glue. Okay? The other thing is, because it's probably using a set of virtual machines that's long-lived, right? They probably aren't, in a lot of cases, we're not recreating all these VMs like we should be. They're just kind of long-lived VMs. And so what happens is that you have to definitely use something called configuration management, which will go out and install patches or packages on those VMs. It will install the software and run the software, maybe do some testing. So I threw that in there as a very large portion of this overall architecture's configuration management. Okay, so here we go. We create our jar file. We're throwing it down here, and we got our 3 stages. We're going to go to test first, then we're going to go staging and production. And so what we'll do is we'll push that jar file, the build or job process, we'll push that out to those different test environments, and it will run through the different tests. Again, these are, if you're good, they're automated tests, but there may be some manual tests too. If that passes, then we get the green light, and we push that over to staging. Again, staging mimics production. And in this case, maybe I've scaled it out to some effect. If it passes that, then we move it to production. Okay? So the idea is we don't want a lot of long-lived VMs, because that equals configuration drift, and that's the enemy, right? How do you track all the configuration changes when someone logs in and manually installs a patch on a VM, right? Because something didn't work right, and then you forget about it. So what we want to do is we want to introduce infrastructure as a service in front of these different environments. And instead of having a bunch of static VMs and networks and so forth, we want to recreate those every time. So demo number 1, here we are. We have, if anyone's done the HOL, some of the container HOLs, we've got this application called vHobby that we use. And in effect, what it is, it's got basically an Apache server, and then we've got a Redis database. In this first example, Frank was able to basically take a container environment and turn it back into virtual machines. But in effect, what's happened is the security team has come to us and said, you know what? 6379 is the default port in which I communicate PHP code, from the web VM down to the Redis database. That's the default, and that's not good. Can't use defaults anywhere. Okay? So what we've been asked to do is to change that port to something else. So we need to iterate the PHP code and how it talks to Redis, and we're going to change that into 6380. Likewise, we've got to go down to Redis and say, hey, incoming calls, 6380. Pretty straightforward, right? So here we are. We commit this code, and what happens is that it goes through testing, and it passes. Great, perfect. We move to staging, and it fails. So we'll talk about why it fails after Frank's done here.
Okay. Can you?
Yeah, we're doing 5.
Okay. All right. So here is our vHobby app. I'm going to go ahead and play. We recorded this yesterday, only to save time. Deployments take a minute here, so I'm going to go ahead and hit play and then annotate over. So I might fast forward through some sections. So this is our vHobby app. It's pretty simple. You can give a rating, give some feedback. When you click submit, you're actually going to see it show down here in the customer feedback. And there's a little demo. Okay. So let's look at what this looks like in an editor. I'm a developer. I'm using an editor here, Atom. It's an integration development environment. So I'm going to go ahead. There's our web application. I'm going to edit this guestbook PHP file because this is the one that's doing the connections to the database. There's our 6379 port. There's the other one that we have a master-slave relation there, so we need to update both of those. Let's go ahead and do that. Okay, so we're updating those to 6380, and then the file over there on the right, that's our abstraction for our database. That's going to update the Redis database side, so we're going to set those up to run on 6380 as well. Okay. Now the next step here is, as a developer, one more step. We're going to upgrade the version there, so it says 1.1 to make sure that we're actually deploying it. So right now you can see it says version 1. So we'll go ahead and update those titles there. And then the next step, what we need to do is now I need to commit that to my source code repository. So I'm going to go to command line, since I like to do command line, and I'm going to run a few git commands here, but essentially I'm going to commit it to my local repository on my machine. You can see the files we changed there. And then the next step would be to push that to a remote repository. So we'll let that kind of run through. So the next steps, once I push to the remote repository, we have a pipeline set up in Concourse. And Concourse is one of those orchestration tools, release pipeline tools that we're using that's listening on the remote repository, and it's going to kick off a pipeline and deploy to our test, stage, and prod environments. So I think we're going to show the pipeline here. There's our pipeline. So you can see it's listening on our vHobby project repository, which is in GitHub. And it has 3 stages there, test, stage, and prod. And I think yeah, there's our vHub. So there's our repository. That's what we're listening to. That's what's configured, VMworld demo. I don't know what I'm doing there. Okay, so let's go ahead and push that. I'm going to go back to my command line here, and I'm going to push those changes to the remote repository. And what we'll see happen here, it takes it a couple seconds, and I might fast forward here just a bit, and we'll see our pipeline kick off. And this is actually just showing the resource, how Concourse listens to the resource. So it's listening on that GitHub for a new version. It'll pull every so often, and when it sees the new version, we'll see our pipeline kick off. Boom. Okay, so the little yellow blinking means that the deployment's occurring. Right now, it's running through a bunch of scripts. And let's fast forward this a little more. And you can see it's just running some deployment scripts there. And let's see, we're going to 740. I'm going to fast forward to more interesting times. Okay, so you see that testing is passed. We ran through some tests in there as well, and now we're on to staging. So we're doing deployments here. It's running through the same step that it did for testing. And let's go to 1050. I'm going to fast forward a little more. Okay, we'll let this play out. So I've deployed. I'm happy right now. You know, I saw testing work, so I know my changes didn't break anything, right? Uh-oh, what happened? This isn't good. You know, let's check this out. So let's click in here, blow this up a little bit so we can view it. Yeah, and we're looking at it, and it looks like deployment worked, but guess what? My test failed. All right, I don't understand it. Worked in testing, it's not working in stage. And yeah, you know, sure enough, we can, if we look at our testing VM, it's updated. It looks good. It looks like everything's there. We'll give it a little test here. If we look at staging and refresh, you'll notice at the bottom here, we don't have our customer feedback. So it looks like something weird's going on. You know, and just to verify, we'll kind of make sure testing still works. Yeah, testing looks good. That's weird. Let's go back on the stage. I'm not sure why this isn't showing up, but it looks like stage is broke.
Yeah?
Yep. Steve, what did you do to the staging environment?
I didn't do anything. What did you change, Frank?
I didn't change anything.
Can you tell I might be the infrastructure person? All right.
Yep.
So, who knows what happened? Firewall rules.
Boom.
So what do we got to do? We got to call up the firewall team. We got to have them change some ports. That should be quick, right? So that's exactly what happened. Testing, it's wide open. You want to be able to have flexibility to do stuff. By the time you move to staging, that better mimic production, right? And so you should better have all those firewall policies all set. And then, of course, production, but it doesn't even get past staging, okay? So failed at staging because of the firewall. So we got to figure out how to optimize this situation, okay? So here we are, infrastructure. Let's talk about the role of infrastructure and how we automate that. So if this is the infrastructure consumer, okay, they typically have their bag of tools, and all these software developers are different. They got different tools. Here I'm showing like Puppet and Jenkins and Git as an example. And normally what they do when they request infrastructure, here's our ops team, compute, network, and storage. Normally when they request infrastructure, they probably fill out a web form. If it's not self-service, maybe it's an email to someone, and you're basically asking for some VMs with memory and CPU and ports and that sort of thing. What happens is that request goes down to the operations team, and they basically have to most likely physically look at something. Now they may have written scripts or whatnot to go automate some of this deployment on the back end. But holy smokes, if there's anything unique about that request, it might break the existing scripting or whatnot. So what happens, These three teams probably don't act in parallel. There's probably some sort of serial nature, so it takes some time. They go away, pound on their keyboards, and you wait. And so what happens is that, yes, it may take days to do this, sometimes months. It just depends on how efficient you are with this. But the worst part is that there could be variability because it's human beings looking at something. Okay? And so what happens, that's step one here of the manual process. Step two is that the information about that unique environment, so that's like IP addresses, SSH keys, those types of things, those are given back to that infrastructure consumer. And what they have to do is they have to take that information and stick it into their tools so their tools can talk to that infrastructure. Okay? And so again, it's another manual process, right, of looking at something and putting this into tooling and make sure you do your cut and paste right. Once they get it right, then their tools, if they're good, they've got configuration management done, they can go push and actually stand up the app on that particular infrastructure. Now, because it took so long to get that, and because they had to hard code all these IP addresses and whatnot, they're going to use that same infrastructure over and over and over again. And they're going to use their tools and they're going to wipe out those VMs and rebuild. And inevitably, again, it's long-lived. You get the configuration drift. That's the enemy, because that results in different environments for dev, test, or test, staging, production. Okay. So what's the alternate method? What have people started to do? The first thing you do is you have to introduce some sort of cloud, public or private. And the reality is, let's just talk about simple infrastructure as a service: compute, network, storage, security. And so this same request, we're going to do this same request, but we're actually going to describe the request in a very specific way with specific syntax. So it's the same, it's the same request here in terms of, here's the instance name. Flavor means basically the size of the virtual machine or instance that gets created. Here's the image used, what network, right? Down here we got network, we got a subnet mask, whatever else, right? So there's a little extra information in here, but it basically describes that entire infrastructure deployment. And so if I've done this right, I can actually front end the app deployment. I can use these same tools to pass it that description down to the IaaS, and the IaaS will spin up the infrastructure. Okay? If it doesn't work, like if I fat fingered or screwed up, you're going to see it, right? And then what do? You go back here and you make your changes and you get it until it's right. And so once it's right, it can be right forever. You can reuse that code wherever you want. So number one, it's fast, but more importantly, it's very predictable. Right? It is what it is from a configuration perspective. So that's one manual process removed. The second manual process removed is because those tools are talking to that IaaS, they're going to get the unique information about the IP addresses and the SSH keys from this environment that got stood up. So I removed the second manual process. And then those tools are going to automatically go out and deploy the app. Okay? So that's the goal here. And then in effect, because it's so easy to do this, to actually deploy the infrastructure as a part of this, that can become short-lived. So now you won't have configuration creep at all. The one thing, when I first started learning about infrastructure as code about 1.5 years ago or so, I heard code, and I'm not a coder. And that kind of scared me. The reality is, infrastructure as code is just this glorified configuration file. Right? So don't be afraid here. Take a look, start to understand it, start small. Okay? So software delivery. So here's my bag of tools here: test, staging, production. The current state is that those environments are different, and that equals infrastructure configuration drift. And the result is variability in terms of of how that software is deployed and tested. So I want to get rid of that. I want to get rid of all these manual ways to deploy VMs. And I want to create this one template here, the code, infrastructure as code, for my topology. Okay? And I want to reuse that topology at every step of the way, so it's the exact same way every single time. And I was talking with one individual, and they said, well, wait a minute, but my staging is different than testing, and so on and so forth. That's great. All I need to do from testing to staging, like maybe I have 10 times the number of virtual machines in staging, I go into my file, and instead of a quantity 2, I type in 20. And so the other thing you're doing, as you're documenting these configurations in files, you can do a diff on the file. So if it worked in test, or if it worked in test and it didn't work in staging, I just do a diff on the file, and I can see what the configuration, that's going to really help me narrow down what's going on in the environment. So there we go. We magically push it to test. There we go. There's all these same environments. Okay, so again, we've got a couple of different options. We've got VMware Integrated OpenStack and vRealize Automation. There's a couple of different possibilities here. So configuration drift is the enemy. Manual untracked changes are awful because that results in less consistency and predictability. Okay. Real briefly, if you're not familiar with what configuration management is, I'm sure you've heard of Puppet and Chef and Ansible. Those are very common ones. The idea here is that I'm going to track configuration changes in all the things. Anything I can, I want to basically write basically a description of what needs to happen, and then I can track those changes over time. So if I look at maybe if I've just got Linux here and I've got Ubuntu here, so it's responsible for application installation configuration, potentially patching, making environment changes, environment variable changes, and so on and so forth. Okay, and then once you get that up and running, there's my different processes that are running there. So it's very, very powerful, but it also takes a lot of work to get it right. But once you get it right, you can reuse that code in many different environments. So the name of the game is tracking all these configuration changes. You saw we used Git as an example here. That's something, I'm sure you've heard of it, version, or sometimes it's called source control. And this is really just a system that will record all the changes to a file or even a set of files so you can recall specific versions later. Okay? And normally what we think about, when you think about version control or source control, you're thinking about my application code. Like, what is that? Those are the folks that are using that. The reality is now, when I think about application code, it's not just application code. It's the configuration code for how to install that app and also prepare the virtual machine for the installation of the app. And then, of course, it's also the creation of the infrastructure under the covers. So when I look at an application, it's not just the app. It's the other things that make the entire app possible here. So that's the way I look at it here. So the main benefit, if you're able to do this, the main benefit is that you get complete visibility to track all the changes. And you can iterate and roll back, which Frank is a fan of rolling back. And it's just, it's hard. It's hard at first, but once you get it, then it's kind of like lifting weights, I think is the analogy, that it's hard in the beginning, but eventually you get into a mode and you can just do all these things. I'll talk about one use case for infrastructure as code because it's kind of related to the demonstrations we're going to do here. And it has to do with like an incident that occurred. And so in this case, we're doing some code development. We're leveraging infrastructure as code. February, everything was great. March, April, sometime between April and May, the security team did an audit or something happened, and there was an issue. And so if I'm using infrastructure as code, all I have to do is I just have to look at how my infrastructure was configured all the way up until May and what changed. And it's literally as simple as a diff, and I think Frank's going to show that in one of the demos here. So in this case, look, someone enabled port 22, somehow that made it out, and it's not good, and so on and so forth. But you can see the infrastructure code probably doesn't change every single time. It's probably fairly static unless they need to up a VM or change the security or something. So you just go through and you find where the change was. Really important. And it's not to get someone in trouble. But you find out who made the change, because they're all tracked, exactly what they did and exactly when they did it. And that's extremely powerful. That's a lot easier than going to syslog, right? So a couple of IaaS options from VMware. VMware Integrated OpenStack, vRealize Automation. I'll spend a little time on the OpenStack stuff because sometimes that's not as familiar. Like OpenStack isn't necessarily as familiar as vRealize Automation is for this crowd. So one thing about OpenStack that you have to understand is that it has evolved from a technology perspective and a value perspective. And the main value that everyone sees here with OpenStack is that it can provide, call it a public cloud experience on-prem. A very friction-free way of getting infrastructure. And so if we look at like AWS, great example, they got EBS for elastic block storage, EC2 for compute, S3 object store, VPC for networking. And then of course the developers can interact with that cloud API. The idea is that we want to be able to do this on-prem in a very reliable way. So I can actually leverage OpenStack on top of the VMware SDDC. Okay? And that's going to give them a very, again, friction-free way to go deploy and configure infrastructure. And I say infrastructure primitives, like compute, network, storage. Like, give me a VM, connect to network. Like, really basic calls. It's not like you're going to the mob of vCenter and trying to figure some things out. Okay? So, OpenStack, a little deeper dive in terms of the architecture here. So again, the big key thing here is that it's got vendor-neutral APIs. And down here, we've got these different services, Nova, Neutron, and Cinder. Those stand for the compute, the network, and the block storage services in OpenStack. And the idea is I can pick and choose what hypervisor, what SDN, and what storage platform under the covers. And that, most folks, when they initially saw OpenStack, like, that's great, I can pick and choose and do whatever I want. The reality is that became a problem because everyone was building snowflakes. And this is a system that has to run. And it became really difficult to patch or upgrade these things. Okay? So, you know, I'm sure you probably heard OpenStack has failed, right? It's not necessarily because of these bits up here. It's because of the overall configuration of the system was unique and it was very difficult to manage. And so anyway, you load the individual drivers and plugins for your respective technologies. And there's actually like another 30 projects in OpenStack. There's an infrastructure as code one. It's called Heat that some folks use. And then there's some other ones. But the reality is a lot of those other projects didn't take off because they couldn't get the basics, like the foundational infrastructure components, stable and correct. So we actually saw this a couple years ago. And we basically said, you know what? We actually own, we own all those virtualization technologies, compute, network, and storage, okay? So what we wanted to provide was a simple, stable, and most importantly, upgradable OpenStack solution. So the way we did that is that we basically said, look, OpenStack has this, I call it an illusion of choice. Like, you can pick and choose whatever you want, but you got to live with the ramifications. What we're saying is you can't use anything else. You have to use vSphere. You definitely should use NSX. You can use any storage technology here from us, so VMFS, NFS, or vSAN, doesn't matter. So in turn, what that means is you can use any storage platform under the covers. You don't need like a specific driver for the storage piece. And if we fix that architecture and use our components, we have a very consistent, repeatable way to deploy OpenStack. So much the way I was talking about earlier, you want this consistent, repeatable way, right? We did the same thing here. We used Ansible to basically do the OpenStack deployment and automatically configure it the best way with vSphere and NSX and our storage. So our motto is like no snowflakes. That's bad. Now, some folks look at this and go, well, you're locking me into VMware. The reality is, you know, initially you would get the vendor independence at the driver and the plugin level. But again, that created instability. You still have vendor independence, you just have it at a different location. So if I'm using VMware OpenStack today and I wanted to move to something else, another OpenStack distribution, I'm using the OpenStack APIs, the same ones that all the other distribution partners have. This is OpenStack. This isn't some special thing that VMware made look like OpenStack. We're pulling from trunk like everyone else. Okay. When I do infrastructure with code with OpenStack, I can do a lot, and I have ultimate freedom. I'm basically given a project with some quota, and I can do whatever the heck I want, right? And that may be scary for some of the infrastructure folks. Like, I don't know if I want people doing that, but that's the way it works. And so as a result, I'm going to create this Heat template, or some folks. Anyone heard of Terraform? Great. Who's using it? Anyone using it? 1, 2, 3, 4. Good. That's what Frank's demo's on. The idea here is that I'm going to track all of this stuff. Now, Terraform actually has a cool feature where you can actually split apart the networking and the security pieces here, and you can actually iterate those independent of one another, which is pretty cool, but he'll show that. Now, the real question becomes, VMware has this flagship product called vRealize Automation. Isn't that an IaaS? Doesn't that do the same thing? And it is an IaaS for certain. It's much more than an IaaS. It does lifecycle management and all this other stuff, of course. But let's look if we're just looking at the infrastructure as code scenario here, or use case. Here's our infrastructure as code. And this isn't exactly syntax right or anything, but just roughly, this is the way it works. I can do infrastructure as code with VRA, but I'm limited to what I can do here. So I'm limited to basically say I've got this blueprint, And my software developers, I can give them access and they can go build this thing. And they can specify web-net and web-security, but what they aren't doing is actually configuring the details around those column primitives, okay? So if you have a security team that they're in charge of writing the security policy for everything, they go write the policy and then it's simply consumed up there in the infrastructure code. So that could be a great thing because I'm now locking that down and those people can't do anything. Or it could be a horrible thing if they need to make a change, like Frank wants to change his database number, so now he's got to open up a ticket and that takes some time and so on and so forth. So it's a balance. And I'm not saying one way is the right way or another. Every organization is different and politics are different everywhere. So Frank, here's demo number 2. Okay. Oh, actually, yeah, let me. Yep. So in effect, same exact scenario here. We've been told we need to change that port here in the PHP code, of course, in Redis. And what we're going to do here, though, is we actually have control of infrastructure code now. Frank has access to that. And he's going to go into the rule here. So not only he's going to make a change to his PHP code, but he's also going to go down to the rule here listed in his infrastructure as code file, and he's going to change from port here 6380 and 6379, 6380. Okay.
Okay.
Yep. 5.
Okay. So Steve mentioned this. This is VMware Integrated OpenStack. So this is our version, right? And this is the Horizon dashboard. We have 3 environments here, test, stage, and prod. And we're going to kind of click through that and show you there. So it's kind of nice, gives you a nice little topo here. So there's our staging environment. You can see the VMs kind of suffixed with stage. I think this one, there's our test that we deployed last demo. And there's our prod. Now, we know that there was a problem with staging. So what we're going to do here is we're going to inspect on this one VM here, this web VM, and we're going to take a look at what that looks like. And notice in here there's a little section called security groups. And sure enough, there's that port 6379 that was causing us an issue on that deployment. So how do we fix this? If we're going to do infrastructure as code, now I as a developer, actually let me pause this here for a second. So this is Terraform. This is the project here. There's our web app. We're using Terraform. Let me expand that up. And the nice thing about Terraform is it allows me to, in a declarative way, identify sections of my infrastructure into files. So we've broken them out into different sections. The main one we're going to be looking at here is the security.tf. This one's going to contain all the rules that are applying the firewall on our VMs. So there's our security file. Over there on the right, you can see there's a bunch of roles in here. And sure enough, there's that port. So I'm going to pause here just for a second. Notice there's a little trickeration going on here. This is just for demo purposes. I don't suggest this, but essentially what we're saying here is any environment that's not test, lock it down to that specific port. So test is kind of leaving a range open so that the test pass, right? So anything in between 6300, 6400, go ahead. Just small note. So let's go ahead and change that to 6380. We'll update the version on our title there just so we can see that it's updating. And we'll go through the same process again where I'll go to command line, we'll commit to our local repository, we'll push that up to our remote repository, and then like before, our concourse pipeline is going to kick off, and it's going to run through the same steps. And at each step, we'll take a deeper dive into what it's doing at each step, and we'll see Terraform kind of do its execution plan, figure out what's changed, and apply that to the environment before it starts doing its deployment. So here we go. I'm about to push the changes here. So this is just the change to the front page, the title page, and then the security policy. Okay. And I think I might fast forward this a bit. Okay, there's our pipeline. Let's fast forward this. So it takes a second for it to realize there's a new update. And you can see, there we go. Now, really quick, notice you can see here, we're running some Terraform commands, and you can see Terraform's running this apply. It's going to actually calculate what it needs to change. And so in testing, because nothing's really changed as far as testing is concerned, there's not much to do, right? So we're just going to go ahead and go on with our Ansible and run through our deployment.
Let me clearly just to make sure it's crystal clear, Terraform won't automatically rebuild everything. It actually sees the changes between what you've declared, right, needs to happen. So it's not going to go rebuild anything unless it actually absolutely has to.
Yep. All right, so we're going to go ahead and fast forward this a bit till we get to stage. Okay, back up just a bit. So testing's gone through, and now we're doing the same thing again here. Terraform's running, but it notices something, right? So it's making its execution plan, and sure enough, there it is, right? It noticed that we made a change to the security file, and it sees that there's a new port there. So it's going to apply these changes to our infrastructure. And once those are complete, then it'll kick off our deployment scripts once again, and you can see the Ansible is running there, doing our deployments. So let's go ahead and fast forward this until, yeah, just so what I'm showing here is I'm going to refresh this page, and you'll notice this is our instance before. Now that that's been deployed out, you'll see this change to 6380. Boom. Okay. So Terraform's done our change in our environment, and I think we also. Let's fast forward a bit there. So let's go to, right here I'm just showing testing. You can see it upgraded to version 1.2. Everything works good now. So that we know we passed that stage. I think I also tried to show some of the Ansible stuff. You can just see Ansible running there. It's not a big deal. I don't think we want to get into that. It's just some of the Ansible code. Let's go ahead. Okay, it looks like staging is completed. Notice it's green now. We can expand that a bit, and we can look at our validate, and our tests are passing now, right? So in one kind of file change, we've updated our infrastructure, and if we do a refresh, you see the version's updated, and it's working.
Yay.
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 Yay, I saved the day.
Good job. Frank apparently saved the day, and he's not...
Not humble.
Not humble, yeah. Okay. So hopefully that helps kind of articulate kind of the strategy. We'd like to basically help out those CI/CD pipelines and make them more efficient, and most importantly, probably a little more stable and consistent. But let's spend some time about containers. Containers are a hot thing. So I'm in the Cloud Native Apps business unit, so we're all about containers, right, and Kubernetes and that sort of stuff. So I'll do a quick little 101 on containers. I did a session on Monday if you want to go watch the replay of that. But in effect here, if I were to look at what containers are and how they work and like the actual tangible benefit of them, I like to compare it like to the way we do things today in a standard Linux host here. So I'm going to pick a distribution. A distribution is made up of management and user space tools, libraries, all that stuff. That's what makes a distribution a distribution. I use my configuration management here, and I actually patch it, set environment variables like we've discussed, and install and run the app. Okay, so then we get our processes running. So this is like probably the way it's done today with configuration management. Now, the challenge here, if you don't have configuration management, things are long-lived. I think I've beat that to death. In terms of what happens, you get the configuration drift. If you are running configuration management, so Frank had to basically take a container world and modify it to be in the VMworld. And he had to go write all this configuration management code to go install and do this stuff. That took some time. A lot of time, he reminds me, for helping me. Here we go. So there's overhead there. And if you do it, you do it right. Containers actually, you hear about like it's resource optimization, they're running fast, whatever. Like the practical benefit, the way I see it here, a really good benefit is that if we look at what containers are, we've got our Docker. This is a standard Linux host, same Linux kernel, okay? But instead of picking like whatever distribution, I'm going to pick probably a specific distribution that's really trimmed down. There's not much in it except maybe the Docker bits, okay? And what I do is, if I issue this Docker run command of a container image, okay, what happens is that I need to figure out what is that container image. That's going to instantiate the container. How do I build that container image? And the container image is built with this thing called a Docker file, which is up there, and you can't see it, so I got a big picture here. And this one is just for Apache. Like you Google Apache and containers, and you're probably going to come up with this. So the first line in this Docker file is called from Ubuntu 12.04. And what that is actually doing is loading all of the package and software and whatever for Ubuntu 12.04. That's like the starting point here. So when I go down and actually run Apache, I issue this command, basically run Apache here. Up here, I did an apt-get and whatnot. I got Apache, set the environment variables, expose 80, so port 80, right? And then I run it. And so what happens, again, I load all of the tools and libraries and software for Ubuntu, and then when I finally go to actually run the Apache service, Apache just thinks it's running on Ubuntu. Okay? So if you think about containers, it's really this operating system abstraction. So VMs are like a hardware abstraction. I like to think of containers as like an operating system abstraction model here. And so as a result, no matter what version of Linux I'm using here, as long as it has a Docker bits, for any given container I can specify what tools, libraries, and software and whatever other prerequisites are required. So that Docker file is very, very powerful, and it actually, if you think about it, it actually takes the place of a lot of configuration management. So I don't have to do all the configuration management like the apt-get update thing. That's built into the Docker file. That's just done. That's just the way it works. Okay, so that takes a lot off Frank's plate in terms of configuration management. So just to highlight, this taboo conversation of containers and VMs that's never supposed to occur, but it always does. Here we go. We got physical infrastructure, operating system, app. The virtual machine abstraction sits here. Okay, so we are abstracting, what the operating sees as the hardware. Like we have a standard set of NICs and storage and whatever else presented up to the operating system, and allows that operating system to be very, call it trimmed down. Right, I only need to load drivers and software for this virtual machine hardware. Okay, and then meanwhile I can rotate out physical infrastructure under the covers. Containers live in this space. So we have this base level operating system here, and then we have the container abstraction that sits there. And a lot of the operating system kind of configuration and so forth, that actually just gets moved up into that container image. So we actually, I don't want to say we're splitting the operating system, but you can kind of divide it into two here. And I can have this ubiquitous operating system layer called the container host everywhere, and then I can run any different type of container across my environment. And some ask, well, do I still need virtual machines? Well, if I don't have virtual machines here, I have an operating system that needs to talk to physical hardware. Typically, if I'm a large organization, I'm going to have to certify that operating system on that specific hardware. New hardware comes out, I got to deal with that. I mean, this is like conversations we had like 13 years ago, right? So there's still value in creating that hardware abstraction, resource utilization. I can right-size that operating system as opposed to bare metal, whatever. We can have a conversation after this, really drill into it if you want. So what we were doing, we were going out to IaaS, we were deploying VMs, networks, security, right? I would then use configuration management. I would go to that environment and I would configure the actual application. The interface, so me, the consumer up here, the interface, I have to understand virtual machines, networks, maybe some subnet masking, like how to write security policy, the to and the from statements that you saw earlier. I have to know that, okay? My core job probably isn't infrastructure, so I'm not really excited about it, but you know what? Because it gives me the freedom to do whatever I want, I'm going to learn it, okay? So I learn the absolute minimum. If we look at the way containers work, and the reason it's super exciting for a software developer here, is that I'm now, instead of interacting with an IaaS, I'm interacting with Docker, the Docker API. I've got this huge place where all my container images can live, and I can pick and choose and copy and paste and whatnot. And I've got this container host I work with. And so in effect, it gives me the freedom to spin things up and spin things down as much as I want, right? I'm spinning up my app and down, and all I have to do is talk to that Docker engine. I got full reign to do whatever the heck I want. I have freedom, friction-free provisioning. The other thing, though, is that I'm not dealing with infrastructure anymore. I have kind of a different paradigm where I'm now talking about container images, persistent volumes, and then just quote-unquote services, which is, how am I presenting this process out to the real world? Like you saw the expose 80, present Apache as 80. So that's my interface. I'm actually working with these constructs as opposed to these. And that's where a lot of folks that don't have experience with infrastructure, they see value there because they can kind of grasp this stuff a lot easier than that. Okay, so when we look at how it applies to the CI/CD process here, the infrastructure configuration becomes greatly simplified because I have this thing called a container host. And you can basically deploy all container hosts the same way. It's kind of this base operating system that everything runs on, that all the containers run on. So here maybe I have different container hosts and test staging and production. And instead of infrastructure as code, I'm actually writing that Docker file, right? And so I basically pass that Docker file, I'm using that and build the container image, and then I run all that stuff in each container host every step of the way. And remember, we want a dev to equal test equal, or test stage equal production here. And so I'm doing that because I'm using containers. You know, the containers are going to run the same way in each one of these environments because they have all that OS dependency stuff built in. So container value props, we were going to simplify the operating system configuration with that Docker file. So it's always versioned and tracked. So if I have this text file that describes the container, I check that into source control. And if things change over time, I can track those changes. It's just built in. And so you can think of, configure. I'm not saying you're replacing configuration management, but it's greatly reduced. It's got a well-known API endpoint. Obviously there's a lot of buzz here around containers, and people are seeing lots of examples of how to do things. But that's a container. What about that container host? I want to just spend a little bit of time on that container host. And so again, it's this ubiquitous, simple, call it the golden image for containers, and you can use it for all containers. Its best practice is that it's still deployed via an IaaS, right? So you use your Terraform and you actually do this, but the reality is it's probably not going to change much over time. So you still have an IaaS here to deploy container hosts, but the number of permutations that exist is really small, or it's a lot less, I should say. So with that, do we want to do questions? Are there any questions? Let's start there, and then maybe we can move on to the demo. Questions? No? All right. You got something?
Yeah. We can, let's just see what this. So what we have here, this is kind of crude, but this is what a workflow would look like for a developer, kind of doing the same thing that we walked through. So here's our Docker file. This is a Docker compose file. This describes all the different services that we have. So you can see here we have the web service, which is our web, hosts the PHP file and then the HTML files. And then below you see there's a couple Redis ones. There's our database configurations. And that's just referencing these different Docker files. So this is an actual Docker file for that vHobby application, right? So it's starting with the PHP base image. It's got Apache on it. And the other ones, there's two other Docker files here. There's the for the Redis database, and they're over here in this data section. And you can see they're starting from a Redis container. That's actually kind of a nice point. So companies like this actually go and publish out to Docker Hub or wherever images already pre-built. So I don't have to do a lot of work to build a full Redis machine. I can actually branch off of the Redis machine there and then do a couple custom copying over of the comp file. So now as a developer, what I need to do, I just need to build my image and then run this Docker compose up, and you'll see all my containers spin up immediately. So I'm on a Mac and I'm running this locally. This is Kitematic. You can see those containers spin up here, and we can see, make sure the app is running on localhost here. And so we'll go ahead and spin it up, and then notice, we have that same problem. We made those port changes, but it's not working. So as a developer, it's very easy for me to go and modify this. Let me just fast forward this a bit. All right. So the way I would do this now is I can just go change these exposed ports, right? Let's change this to 6380. And if I had a little more time, I would have pipelined this, do a little search and replace, but I have to update the Redis comp. We didn't have time to kind of automate that. But I would make these changes. I would go through that same process where I would check them in. We didn't have time to do a release pipeline for the containers, but we can show it locally here. I've made those changes. I'll up-rev the version here. And then I can spin these back up, so I can rebuild my images and bring them back up. And you can see that process was a lot faster actually than the other one, right? Now that I'm dealing with containers, I can iterate extremely quick. There's our updated version, and Docker works, right? I did that in a matter of 3 minutes, as opposed to the other one that took probably about 15 minutes.
Yeah, there were no to and from statements per se. It was like, port this, and that works.
Yep.
And I'll also add, so we did this on containers. We wanted to do it on Kubernetes, and actually show an actual deployment and whatnot. And in a Kubernetes deployment file, you can actually specify security rules. And what happens with our integration with NSXT, which is our version of NSX that's going to support containers, an application developer can write the security policy as a part of Kubernetes, and via the networking interface, container networking interface, it will take that Kubernetes deployment and will enforce microsegmentation down to the container level or pod level in Kubernetes. So it really eliminates a lot of steps and whatnot. You've got one place where you're making these calls and then it's pushed out, but the enforcement is done basically by a production grade.
You can talk about the changes to the host versus container level security?
Yeah, so the container host can also have security applied to that as well. Okay, any questions? Yes.
Okay, so the question is, are you asking about the Terraform JSON? Is that what you're referring to? Okay, so it is kind of it's a YAML format. It's not particularly, it's JSON-like, but it's a YAML format. And then the other part of that question is, with the containers, we're changing it here in the Docker file. Is that the question, or?
Yeah, so you mean the first one, you did the CI/CD of container versus doing container.
Yeah, the first two demos were all virtual machines and using Ansible for configuration management and whatnot. And the contrast was that, okay, if I was going to do this in the container world, how does that change things? Like, where do I make these changes in the container world? And that's done in the Docker file as opposed to the Ansible code for configuring VMs. Does that make sense?
As a developer, I'm only dealing with the container, because that's the only thing, because Docker manages all the different network connections and does a lot of that because it's running inside of a container host. So I don't have to worry about a lot of that. I can do it, in the single place. That's the simplicity why developers kind of migrate towards containers versus IaaS. It's a good question. Any other questions?
Who wants to go do this? Hey!
That's a good point. Even this simple app took a lot of work. So this isn't easy, right? The release pipelines, there's quite a bit of work. So.
Yeah, and I think it was Frank that told me most software pipelines are broken to some extent.
Yeah.
It's hard to optimize, right? But in effect, if you're able to optimize that software build process, you get the business what they want, which is speed and agility. Being able to make those changes in an efficient way if you've automated this. It's not easy, but if you're able to do it. Yeah, okay, so the question is, for the container host, how does Photon OS play a role? Thanks for calling that out. So VMware, we actually have our own container host, or we have our own Linux distribution, okay? And it's called Photon OS. We actually use it for the VCSA. We use Photon OS everywhere, or we're going to use Photon OS everywhere internally at VMware for all of our software products, okay? It's also available, it's open source, you can go get it. It's super stripped down in terms of what's on it. It does have Docker in it, so you could use that as your container host. Okay. One thing it is, we call it optimized for vSphere. What the heck does that really mean? The reality is we only load the drivers and whatnot into that container host OS that need to be there in order to run as like a VM, right? We don't have to go grab all these different RAID card adapters and this, that, and the other thing. We can basically strip down all the different drivers and whatnot that are in it, so it's highly optimized. I forget the exact amount of megabytes, but it's really small and it boots up in like 20 seconds. You can do it on, not 20 seconds, like a lot less than that. But you can do it on your laptop, works really well. So, anything else? Okay, thanks for coming.
Thank you, guys.